Good afternoon, everyone. My name is Petru, and today Alex, Ethan, Tim, and I will be presenting our new and exciting app called langsnap. The aim of the app is to make the task of learning a new language easy, fun, and interactive. It's an all-in-one tool which includes a translator, the ability to save the words which you translate, a quiz, and provides details on how you're performing every day. The main feature of our app is the ability to identify objects within the user's environment quickly by using the TensorFlow.js machine learning framework and the pre-trained MobileNet version 2 model. This introduces the user to words which they commonly use and helps them remember the words in the new language by creating a visual link between the object itself and the word in the new language. In contrast with some of the other apps available on the market today, you don't have to sign up or pay for it in order to begin using it. So, let's get started. As we open the app, we are immediately taken to the main page, where the video camera captures objects which you film and displays their English name below the screen. Once you're happy with the word, simply select the language and press the Translate button to get a translation. The detection of the name of the objects is made possible by the TensorFlow.js machine learning framework. To unlock more features, you must complete a quick sign-up form using your name, email, and a chosen password. But for the purposes of this demo, we will log in as an existing user. The authentication process is of course handled by Firebase in the back end. As a registered user, once you translate the name of an object, you can then request a list of verbs, adverbs, and adjectives, each with an accompanying translation, made available from the Associated Words API. This feature is meant to help the user form sentences. And every time a registered user clicks on the Translate button, the English word and its translated counterpart are saved in the words list section of the app. A user must translate words before they appear in the words list. The Account section of the app provides a graph which details the amount of words in each language that a user has learned. Another key feature of our application is the multiple choice quiz. To begin, select a language in which you want to take the quiz and simply click on the correct answer. It is worth noting that the user can only access this feature once they have translated more than 2 words in a given language, so that the app can generate a random list of words in the language that you select. If you want to take the quiz in a different language, and you have translated enough words in the language, click on the button below and select a different language. The more words you have, the longer it will take a user to get through the quiz. Once you are done, you can safely log out. Next, my colleague Ethan will describe the technologies used on the front end in more detail.
Hi, I'm Ethan, and I'm going to be talking you through the front end of our application. For the front end tech stack, we use React to build our app, TensorFlow for machine learning, and vanilla CSS for styling. This was a mix of new technology and technology which we had learned on the course which we wanted to put into best practice. Because of this, we had an idea of what we needed to do, and we were capable of building our application with these skills previously learned. One of the things that was new to us was TensorFlow. TensorFlow is a machine learning framework in which we use to deploy the MobileNet version 2 model to detect objects in real time. In the early stages, as a team, we all spiked out this technology in order to get to grips with it so we can start on our application as soon as possible, as without this feature, our app would simply not work. After spiking it, we came together in a stand-up and collectively shared our findings, and from there built a simple camera implemented inside the browser. We wanted our app to be browser-based as this would cater for all devices. We found that the barrier for using TensorFlow was very low and the documentation is very easy to follow. For the user interface, we use React. React was used to display the predictions in order to detect what TensorFlow was picking up. Using this meant there were lots of re-renders every time a new object was detected. Therefore, we wanted to only re-render a small part of the page, but it needed to change regularly. We had a clear vision of how we wanted the app to look. We initially considered styling with frameworks like Bootstrap and libraries such as Tachyons, but found that it would be just as easy to use vanilla CSS. Finally, as a test suite, we use Jest to use on any utils functions throughout the app by using TDD.
Hi, I'm Tim. I'm going to be talking through the back end of our project and the technologies that we've used. At the outset, we decided we wanted to leverage the back end of our project to help us build a robust and secure application. To achieve this, we've used a number of technologies. The first of these was Express. We chose Express as it provides an unopinionated server framework that allows for the integration of third-party technologies. We integrated Firebase auth middleware to ensure that the safe storage of passwords are handled by a third-party system that is robust and tested. And furthermore, it gave the advantage of having a protected API route to handle sensitive communications from the front of the application to the relevant services. With the authorization middleware installed, we chose to partner our application with the Firebase real-time database. Our application has very little relational data, and as the functionality of our application must be built on individual slices, we could leverage the flexibility of a non-relational database to achieve continual service as we progress through the build. As there are a number of third-party APIs integrated into our application, with the exception of TensorFlow, we chose to fetch that data from our backend. Doing this ensured that we could control the errors and that the front end of our application had a defined set of responses for each API call. TensorFlow can be deployed in a number of ways. The two we explored in detail were installing as an npm package or requiring in as a CDN. During our initial spike, we had already migrated from MobileNet v1 to v2, and rather than update dependencies, we used a CDN file within our application to make the API calls to TensorFlow. This ensures that we've always got the latest version of TensorFlow running in our application. Naturally, we had a large number of API calls to make, and to ensure that we could leverage the power of those third-party applications, we employed Axios. Axios gave us the ability to write multiple queries and therefore reduce the number of models in our backend. This was to ensure our code was as dry as possible. We used Mocha and Chai to ensure that each route in our application is tested, as Mocha and Chai allow for specific assertion tests, and the before and after hooks allow for clean tests with proper setup and teardown. Finally, we hosted early with Heroku. This was to ensure that development work for the front end of the application could continue at pace, and we could continuously deploy after each new feature following robust testing. Okay, so on to technical challenges. Naturally, the largest technical challenge we faced on this project was TensorFlow and integrating that with our application. TensorFlow was originally designed for a static web page, and we need to make it work with the virtual DOM for a React application. This meant ensuring that the canvas and video feed was kept alive even when the React virtual DOM re-rendered. As TensorFlow makes an API call, we had to control the number of calls made and the accuracy of the result returned. To achieve this, we had to create a function that could control the frame rate and the API calls, therefore controlling the rate of prediction. With this function, we could dramatically increase the accuracy of the information presented to the user. And furthermore, we wanted our application to work on low-powered devices and to be accessible to anyone with a browser. As a result, it was imperative that we reduce the load on internal computing resources and data. Finally, we used some random logic to operate our game, and this created a number of issues. The greatest of these was how to ensure that the user was not presented with the same game twice. If we had to do the project again, we would look to use an alternative logic to ensure that the game is played in a specific pattern. Thank you.
Hi, I'm Alex, and I'll be talking about our use of Agile Practices and the possibilities of future development for our app, langsnap. We knew that from the outset we would be working entirely remotely for this project. Because of this, we knew that communication and thorough preparation would be key to achieving the minimal viable product. As the project would be front-end heavy, we decided that rather than splitting the project into front-end and back-end and dividing our team as such, we would split the project into multiple slices. This would mean at the end of each slice we would have a functioning product, and as a group gave us the opportunity to review our progress and decide if any changes should be made. It also gave us the chance to be flexible with assigning tasks to each member and gave us all a deeper understanding of our app. To stay organised, we made a Kanban board for each slice with Trello and designated tasks to pairs. We held 3 stand-ups a day to ensure continued communication within the group and to maximise the time and resources we had by keeping everyone on track at all times. When designing and wireframing the app, we used Figma, Xmind, Pinterest and Google Docs, which can be edited online and meant we could all easily contribute. We used Zoom and VS Code's live share to work together, which other than occasional internet issues worked well and mostly meant the remote workflow was seamless and unproblematic. When it came to using GitHub, we varied our practices depending on what was required for that specific slice. When approaching a project together, we used truncated development. But when working apart on features such as the quiz, we found branching using the Git flow style worked better. It was important for us to get the backend hosted early, as we knew we'd need to make use of it when building the front end. We also knew that spiking out the object recognition side of the app would be one of our biggest obstacles, so we worked on those elements simultaneously. When it came to building our front end, we had a robust server and a good understanding of the technology we would be implementing. We also hosted the app pretty early on in the development stage. This meant we could continuously deploy the project to test it on our mobile devices and get feedback from our peers, which we used to seek out bugs and develop the app's features. It was genuinely a pleasure to work together in this team. The fact that we got on so well meant that staying honest and constructively critical of each other's code was not a problem. We often mixed up the teams during pair programming, and the work was always fun and productive. I'd like to say thank you to everyone for watching, from myself, Ethan, Petru and Tim. We had a really good time on this project, and we hope you have fun with langsnap.